Effect of solvent polarity in UV visible spectrophotometer. So solvent polarity means the separation of charge in the solvent. For example, if we take a polar solvent like water, methanol and ethanol, we have in that heteroatom like oxygen which has a high negative charge. So we have a partial charge separation inside of the molecule. So it will have a high dielectric constant and thereby can dissolve ionic substances. Likewise, non-polar solvent won't have any such heteroatom in its structure. It will be purely hydrocarbon also, like hexane, benzene, toluene. So they don't have any charge separation in itself also. So it will have a, it is not dipolar, so it is having a low dielectric constant and it typically used to dissolve a non-polar compound. Now impact of polarity on solubility is, so if you take a compound which is polar, it can be dissolved only in a polar solvent. Likewise, a non-polar compounds could be dissolved using a non-polar solvents only. Like like sodium chloride is like polar, so it can be dissolved in polar solvent like water. But another substance which is very less soluble, like the substance which are not having charge separation can be dissolved in non-polar solvent like kerosene. Likewise, so there is a popular saying that like dissolves like. Now we can see this energy diagram. So this is the energy level diagram. From here the energy level goes to here, so it increases like this. And these are the various level pi, n and pi star. This is double bonding orbital, this is non-bonding electron orbital, and this is double bonding anti-bonding orbital. So we can see the pi to pi star transition, the delta E of it is large. And this is the n to pi star transition. We can see the delta E, which is nothing but the higher level energy level minus lower energy level, is comparatively less. And we can see that when we talk about polarity, we should understand this concept first. Non-bonding orbital is most polar, and after that anti-bonding pi star orbital, and then it is followed by bonding pi orbital. So this is the order of polarity. So this has to be understood first in order to understand about the solvent effect. So with polar solvent, what happens is these energy levels, as I told you, N bonding is the most polar, so its energy level will be drastically reduced when compared to the pi star orbital, which compared to the pi orbital. So its reduction will be most, N bonding orbital will be, energy level will be mostly reduced in polar solvent. So due to this, the N to pi star transition will have the delta E value to be very less. So it shifts to a shorter, the delta E value, actually the delta E value is the higher energy level will minus the lower energy level. Since the value of N is drastically reduced, this delta E value will be more. So due to this, energy is inversely proportional to the wavelength. E is equal to hc by lambda. So energy is, if it is more, then the wavelength will be less. So it will shift to the shorter wavelength region, or blue shift or hypsochromic shift will occur for N to pi star transition. So we'll see what happened to pi star transition in polar solvent. So this, when compared with this transition level is less. So less energy means more wavelength. So it shifts to the longer wavelength region, or bathochromic shift or red shift happens. With non-polar solvent, what happens we'll see. Non-polar solvent like hexane, benzene, toluene, what happens is, as I told you, N won't change much because it's most polar bond, non-bonding orbital. And when compared to N, pi star will be slightly reduced and pi will be more reduced. So what happens to the transition we will see. N to pi star transition, if you see, its delta E value will be less. So it shifts to del E, energy is less means wavelength will be more. So red shift happened. but pi to pi star will be more when compared to here. When compared with here, delta E value of pi to pi star transition is more. So due to this, wavelength will be less, so blue shift happens. Now we'll summarize this. N to pi star transition in polar solvent, hypsochromic shift happens. In non-polar solvent, bathochromic shift happens. Pi to pi star transition in polar solvent, bathochromic shift happens. And non-polar solvent, hypsochromic shift happens. Thank you.